If your first move is to paste a giant error log into Codex and write, "Fix this," you are giving the agent a guessing game. Sometimes it works. But on real projects, it often creates a second problem: the error disappears, but nobody can prove the original bug was fixed. This video is about a safer loop. Stop pasting errors into Codex as raw noise. Build a minimal repro first. A minimal repro is the smallest repeatable way to make the bug happen. Once you have that, Codex is no longer guessing from a stack trace. It is working against a specific failing path. The debugging loop is simple: triage the scene, build the repro, make the smallest fix, then rerun the same repro. The first mistake is treating an error log as the whole bug report. A long stack trace usually contains useful clues, but it also contains noise, unrelated warnings, framework wrappers, old logs, and lines from code that only happen to be nearby. If you ask Codex to fix everything in the log, it may change files that were never part of the failure. It may patch the symptom, add broad defensive code, or refactor around the problem instead of proving the actual trigger. Before any edit, ask Codex to inspect the error scene. The question is not, what code should we change? The first question is, what do we know? Ask it to identify the key error message, the first project on frame, the command or user action that triggered the failure, and the files that are probably involved. Also ask it to separate evidence from guesses. That one distinction matters. A line in the stack trace is evidence. A theory about a stale dependency is a guess until something confirms it. After triage, turn the bug into a minimal repro. For a codebase, that might be one failing test, one CLI command, or one short script. For a front end, it might be a fixed browser path: open the settings page, click save with an empty name, and see the crash. For an API, it might be one request with stable parameters and a known expected response. For a document, image, or video workflow, it might be a file check, a text scan, a dimension check, a duration check, or a frame extraction. The format can change. The rule stays the same. A good repro is small, repeatable, and specific enough that somebody else can run it. It should fail before the fix. It should point to one failure, not a bag of unrelated problems. And it should be cheap enough to run again after the change. That is why "the app is broken" is not a repro. Run npm test with this one test file and it fails on this assertion is a repro. Click these three controls and the submit button stays disabled is a repro. Send this JSON payload and the API returns 500 instead of 400 is a repro. Once the repro exists, you can ask Codex to fix the bug. But keep the fix intentionally narrow. Tell it to change only the files directly connected to the failing path. Tell it not to refactor adjacent code, not to rename unrelated functions, and not to add broad fallback logic unless the repro proves it is needed. This is where many AI debugging sessions go off track. The agent sees a bug and tries to improve the neighborhood. That may feel helpful, but it makes review harder. When a bug fix touches 10 unrelated files, you no longer know which change fixed the bug, and you have more surface area for regressions. A strong handoff explains the minimum change. It should say what caused the failure, what was changed, and why that specific change addresses the repro. Then comes the part you should never skip: run the same repro again. Do not accept "I fixed it" as the verification. Do not accept the error should be gone. Ask Codex to run the exact failing test, command, browser path, request, or file check that failed before. If the repro now passes, ask for the evidence. The useful final answer is not confidence. It is proof. For example, before, the test failed with this assertion. After the change, the same test passes. Before, the API returned 500 for this payload. After the change, it returns 400 with the expected validation message. Before, the rendered video had the wrong subtitle timing. After the change, these extracted frames line up with the scene timing. This is also where you scan for collateral damage. Ask what files changed. Ask what checks ran. Ask whether anything was not verified. And if the project has no test suite, make Codex say that clearly instead of pretending a test passed. Here is the first prompt I use for the diagnosis phase. Do not fix yet. Read the error and the relevant project context first. Identify the key error, the likely trigger, the first project-owned stack frame, the files involved, and what is evidence versus assumption. Then propose the smallest reproducible case we can run before changing code. Here is the second prompt for the repair phase. Use the minimal repro as the target. Make the smallest code change that addresses that repro. Do not refactor unrelated code. After the change, rerun the same repro and report the exact command, result, changed files, and any risk that remains unverified. Use this loop when the result matters. Use it before committing a bug fix. Use it before asking an agent to patch production-facing code. Use it when a UI failure, a PI failure, test failure, or generated artifact needs to be trusted later. The point is not to slow Codex down. The point is to turn a vague error into a verified repair. When you have a minimal repro, the agent has a target. When you rerun that repro, the handoff has evidence. So the next time Codex sees an error, do not start with fix this. Start with make this fail in the smallest possible way.